Hello students, welcome to the SMSC, the Engineers Class Digital, and our topic for today's session is application of Ohm's law. What is Ohm's law? Just let it watch. According to the Ohm's law, according to Ohm's law, the potential difference across two ends of a conductor is directly proportional to the current flowing through it when it is connected to a source. So we can represent it as potential difference that is denoted by V is directly proportional to current flowing through it, that is I. Or we can say it V equals Ri, where R is proportionality constant. Please note it down on your notebook, and then we have to escape. Okay, now I am mapping this board. And now I am writing Ohm's law, that is V equals Ri. Now we have to deduct the formula of Ohm's law, so we have to consider a conductor of length A. Now we have a conductor that I am drawing on the board of length L, and it is connected to a source. A potential difference V. By connecting the source, it creates an electric field that is positive charge on this ends and negative charges on the other end. It creates an electric field. Through this electric field, it attracts the electron in a particular direction, and electrons that are free in that conductor are attracting in the direction of electric field that is on the positive ends of the conductor. The flowing of conductor electron has the velocity that is known as drift velocity. we can define the drift velocity such as the velocity required to maintain the current in the conductor. It is drift velocity of current that is required to movement of electrons in a particular direction, and the direction of flowing of current is just opposite the flowing of electrons. So drift velocity that is denoted by Vd equal to E capital E tau upon m, where Vd denotes drift velocity, E denotes charge of electron, capital E denotes electric field that is generated through the potential difference, and tau is the relaxation time. And now m is mass of electron. So please note it down, and now I am wiping it, so freeze your screen and note it soon. Before this topic, I have also studied about the current that relates to the drift velocity, and the relation is as follows, and that is current I equal to Vd ENA, where Vd as previous drift velocity, E charge of electron, in number of electrons passing through the cross-sectional area in a particular time, and A is the area of cross section of conductor. We have another lesson, so you should freeze your screen again and note it, and I am writing it again. Firstly, I am marking it as equation number 1, equation number 2, equation number 3, and on another lesson that is related to potential difference and electric field, and the lesson is potential difference or E for electric field, and R, we have the value of R here is the length of our conductor, that the distance is covered by the electron. So that is represented as L. Now we have put the value of potential difference in the equation number 2 to form the potential difference in this equation. So now I am writing again the relation of, or we can say the formula of drift velocity, that is E tau upon m. Now multiplying by L on numerator and denominator of right side. Now we have drift velocity equal to E tau upon m into L upon L, or it is represented as, from equation number 2, E into L can be written as potential difference V. So we get drift velocity from our equation number 3, that is current equal to VdENA. Now we have to put the value of drift velocity in equation number 3. Then current I equal to VdENA equal to the value of drift velocity is E tau V upon ml ENA. Now I am seeing that E into E and N, firstly I am writing N E into E square V tau A upon ml. Once again, by forwarding this relation, now I am writing it again here, that is I equal to NE square potential difference V tau A upon ml, or V upon I equal to ml NE square tau A, or V upon I equal to m upon NE square tau L upon A. Just we got the relation for V upon I, and now I am seeing here m is the mass of electron, that the value taken as a constant, because mass of the electron cannot be changed, and the number of electrons that is passing through the conductor due to the source cannot also be changed, because I know the potential difference is same for the conductor. If we cannot change the potential difference, then number of electrons cannot be changed. Again, charge of electron, that is represented as small e, cannot be changed, and it is also a constant value. And the relaxation time is also a constant. Since I have a conductor of length L and its cross-sectional area is A, that cannot be changed if we don't want to be. So, about the value that is totally a constant value and cannot be changed. So, we can rewrite as V upon I equal to constant. Now, I am taking it as equation number 5 and just comparing it from equation number 1. I have from equation 1 V upon I equal to R, and from equation number 5 V upon I equal to constant. So we can say that R is a constant and this relation relates to V equal to Ri. That's the statements of Ohm's law. We have so many formulas related to Ohm's law, and now I am showing to this formula and we have to use it from some questions and solve it. Let's we have to use some formulas related to Ohm's law and the topic related to current, that is work, power and energy. So the formula of power saying that power P equal to V into I. Now we have the some formula that should be V equal to IR according to Ohm's law, and I am putting the value of Ohm's law Ri here. So I get formula for power P equal to I square R. Now as formula for power, that is P equal to V into I, and now I am putting the value to displace the current, that is V equal to IR. So I should be I equal to V upon R. Now I am seeing it as V square upon R. For the power, we have the formula P equal to I square R oblique V square upon R. For the resistance, we can say it as V square upon P. Note the formula, and now I am applying it in our questions. And we have the question on your screen board, that the question is asking a lamp of 100 watt works at 220 volts. What is its resistance and current capacity? Now it is a simple question. The question that relates the formula of Ohm's law and that is related to power. So from the question we have the term given, that is power of lamp that is P equal to 100 watts, and the lamp is working on potential difference, that is V equals to 220 volts. So we have to find the resistance and current. Resistance R equal to V square upon P, that is V square, that is V upon P, that is 100, and that is 48400 upon 100, and cancellation of twice 0, we have resistance of 484 ohm resistance. It is the resistance of lamp, that is 484 ohm. Now I am calculating the value of current that is flowing through the filament of that bulb, and that is power P equal to I square R. We can also derive it as from the formula, that is Ohm's law, easily. So we can use the formula related to Ohm law, that is V equal to Ri. It can be easily to derive the value of our current. So current I equal to potential difference upon resistance, and the current I depends on the potential difference V equal to 200 volts, and the resistance is 484. By terminating it as, or we can calculate it 0.45 ampere, approximately value of our current. So we have the answer resistance and current I equal to 0.45 ampere. Note it down, and now I am skipping, and we have the question on our screen, that is a cell develops the same power across two resistances R1 and R2 separately. The internal resistance of cell is. Here is the question relates to the outer resistance of the circuit and the internal resistance of cell that has the potential difference on its terminal and its internal EMF, that is relates to E. So according to the question, we have the terms, the power is same for the resistances R1 and R2 if they are joined it separately. Then firstly, power that is dissipated is denoted by P1 if I am joining the resistance R1. And now I am putting the value of power P2 if the resistance R2 is connected to the outer section. Now we have power equal to V into I. Then P1 equal to V into I1 and V into I2. Potential difference is relates to E, and here we can rewrite it as E. So we have to find the value of current I. What is the value of current I that is flowing through the circuit So current I1 equal to V upon R, and here the potential difference is taken as EMF of the cell, and the value of resistance here is internal resistance, that is taken as small r, and outer resistance of the conductor, that is taken as R1. So the power 1 is I1 square into R1, and the value of I square is taken as E square R plus R1, that is whole square, into R1 equal to E square R1 upon R plus R1 whole square. Now the power P2. For the power P2, current will be changed if we are changing the outer resistance, and now the current is taken as I2 and the square of I2 square, and the resistance are 2. So the value of I square is taken as potential difference is same, so, and internal resistance is R, and it is also the same, and outer resistance R2. From the question, the power P1 and P2 is same. Then, now I am taking it as equation number 1 and another as equation number 2. So we can say that from equation 1 and 2, P1 equal to P2, so E square R1 equal to R plus R1 whole square equal to E square R2 upon R plus R2 whole square. By cancelling of E square from both sides and calculating it as R1 R plus R2 whole square equal to R2 small r of internal resistance and R1 whole square. It is taken as R square plus R2 square plus 2 R2 equal to R2 R square plus R1 square plus 2R R1. By multiplying it, we have R1 R square plus R1 R2 square plus 2 R1 R2 equal to, and multiplying it again, R2 R square plus R1 R2 R1 square plus 2R R1 R2. By cancelling this value, 2R R1 R2 and 2R R1 R2. By terminating it, we have the value R1 R square plus R1 R2 square equals R2 R square plus R2 R1 square. Now I am taking the value of r square from this term in same side. So it is written as r2 r1 square, that is going from the same another side r1 r2 square. Here the r square is common and r1 minus r2 is separating from it. Now here r2 r1 square, r1 r2 square, so we can say that r1 r2 is common on both sides and r1 minus r2 is taken as separately and bound, and by cancelling of this term we can get r square equal to r1 into r2, and the internal resistance of cell for the condition is mentioned according to the question, that is r equals under root of r1 into r2. And now we have cleared our equation, that is r equal to under root capital R1 into capital R2. So freeze your screen, and now I am skipping another question for you. Valve 1, power of valve 1, that is taken as P1 equal to V square upon R1, and the power of second valve is taken as P2 equal to V square upon R2. By comparing the power of valve P1 upon P2 equal to V square upon R1 equal to V square upon R2, or P1 upon P2 equals to R2, and by cancelling of V square, R2 upon R1. Now I am putting the value of power of the valves as power P1 equal to 100 watts and power P2 is given as 500 watts equal to R2 upon R1, or R1 is 5 times the R2. From the circuit, the current flowing through it is same for valve 1 and valve 2 since it is in series. So current will be same for the valve 1 and valve 2. So the power dissipated by valve 1 is P1 as I square R1, and power dissipated by valve 2 is P2 I square R2. By comparing the power of valves that is connected in series is taken as and I is cancelling here. Value of R1 that's led to is 5 times of R2. So we can, in the place of R1, 5R2 upon R2. By terminating R2 and R2, we have P1 upon P2 equal to 5. Or P1 equal to 5 times the P2. Now I am seeing here the power dissipated through the bulb 1 is 5 times the power dissipation by the bulb of power 2. So we can say that the dissipation of power of bulb 1 is more than, or it is 5 times greater than the power dissipated by bulb 2. So the power is consuming by bulb 1 is more. So the brightness of bulb 1 is more than bulb 2. So we got the answer, and now it's time to saying bye to you, and I am requesting to you, please subscribe my channel and continue to watch my videos on YouTube, on our Facebook channels. That links are in represented in the comment box. So please continue our video to watch and keep support us. We will meet again. Let's bye and see you again. Keep learning, keep watching.